Hello, everybody, and welcome to the Astro Show, the place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here you can pick the brains of astrophysicists, get advice from an aerospace doctor, find out what astronomers and other scientists have to say about life, and find out what's going on up above your head, all in the same place. So we hope that you join us every second and fourth Tuesday of the month at 6 p.m. Mountain Time on Facebook, Twitch, and on YouTube. In this week's show, we have Amaya Sinha, a graduate teaching assistant from the University of Utah. Among other things, Amaya studies the chemistry of open star clusters. We will hear all about that later on this evening, but before we get there, let's welcome our co-stars. First, Assistant Professor of Astronomy at the University of Texas at Austin, it's Dr. Nick Galitsky.
Hi, everybody.
Hey, Nick. Good to have you with us tonight. Next, aerospace doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hi, everyone.
Hey, Danny. Glad you could make it.
Me too.
Hope everything went well at the hospital this evening.
It did.
Okay, good. And last, but certainly not least, astronomer and data visualization engineer at the Adler Planetarium, it's Dr. Lauren Corleys.
Hi, good to be here.
Glad to have you. And now let's welcome on our special guest, graduate teaching assistant from the University of Utah, Maya Sinha. Thanks for joining us.
Hi, how are y'all doing?
Doing well, thanks. All right, let's get going with tonight's show. As always, we'll start with astro advice. I'll read you the quotation, and then you'll have a moment to make your best guess at who actually said this. So, we travel to learn, and I have never been in any country where they did not do something better than we do it, think some thoughts better than we think, catch some inspiration from heights above our own. Your four options are Maria Mitchell, Marie Curie, Mary M. Daly, and Mary Leakey. There's a theme with the first names, if you didn't catch on to that. Thank you, Maggie, our operations director, for having some fun with that. So, of course, Maria Mitchell was the American astronomer, librarian, naturalist, and educator. She was the first woman to lead a all-women scientific expedition to the state of Wyoming, nonetheless, to see the total solar eclipse, the date of which I can't remember now. It was 1800s. But yeah, she successfully captured sketches of the eclipse through her telescope, and they turned out to be much better than what the Edison camp did for that total solar eclipse. Thomas Edison also came out to Wyoming for that eclipse, but apparently Maria Mitchell's sketches were better than his. So that's one option for that quotation. Two, Marie Curie, the Polish and French naturalized physicist and chemist, who did incredible pioneering work on radioactivity. Not only was the first woman to win a Nobel Prize, also the first person to win a Nobel Prize twice, and remains the only person to win 2 Nobel Prizes in different scientific disciplines. So, second option is Marie Curie. Third, Marie M. Daly, who was an American biochemist, the first African-American to receive a PhD from Columbia University, and also first Black woman in the United States to earn a PhD in chemistry. That's your third option. And last but not least, Mary Leakey, the British paleoanthropologist who discovered the first fossilized proconsul skull, an extinct ape, which is now believed to be one of the ancestors to humans. So those are your 4 options. And we've got that slide in, and this time I did not go to the answer before I'm going to give you a chance to actually cast your votes. So what say you, everybody? Whenever you have an idea, you can just unmute yourself and let me know what you think.
I'm going to go with D.
Okay, we've got 1 vote from Dr. Danny for Mary Leakey.
I'm going to go with A.
All right, 1 vote for Maria Mitchell from Amaya.
I was going to pick C, Marie Daly.
Okay, Marie Daly from Thorin.
I guess just put me down for Mary.
Interesting.
1 point for Nick.
Nick gets a point for being catty.
But no, fine. I can fill out the spread and go for B.
Okay, all right. We got 1 vote for everybody. The correct answer is Maria Mitchell. Nicely done, Amaya. 1 point for Amaya. And we do keep track of points, just so everybody knows. Okay, moving on to Astro 3. Oh, we didn't even talk about that quotation. What am I doing? Sorry, I'm jumping the gun. We started a little bit late, so I'm trying to get us caught up, but that's okay. So what do y'all think about this quotation?
I agree with it completely. I found the same thing. The more I travel, the more I learn. And I feel like it's been very interesting with some of the traveling that I've had the privilege of getting to do over the last however many years. That I have thought this exact thing before. So
Nice.
Is there like 1 trip in particular that's springing to mind where you're like, I never would have learned that without traveling there?
I don't know that there's necessarily one. Just, I find each time I travel, instead of bringing back like knickknacks or things like that, I try to learn something new, whether it be a way of cooking something or, just a way of viewing things. And oftentimes there are really deep insights that I've just learned from folks from other countries. I guess maybe there is one that's been really profound. When I took a trip to Rwanda and did some medical work there when I was in medical school, it was 18 years after the end of the genocide. So I was there for like the anniversary of the end of the genocide and everything. And it was still, Rwanda was very much still in the midst of this like rebuilding process or rebuilding period, and learned lots of things. So, yeah.
Nice. Anybody else? I have a traveling example as well. It doesn't really fit in perfectly to this quotation. It was the lesson that I learned about needing less than I actually thought that I did. Not out of choice, but out of necessity when I got robbed. I was in Tacna, Peru, and I was warned about the bus station in Tacna that I should be careful and watch my belongings. And some seemingly really nice guy sat down next to me and started chatting me up, and he was very patient with my Spanish. And I don't know, 5 or 10 minutes later, after he was apparently done talking to me, he looked at his watch and said, "Oh, I gotta go, I'm late," and stood up and like ran out of the bus station. And I looked next to me, and the bag that had been sitting right up against my leg was no longer there. So it was a good guy, bad guy scheme. I never even saw the person who took my bag. But then for the next month, I traveled just with a little day pack with 1 change of clothes. And it was awesome. And I've always traveled really, really light since then. So not quite what Maria Mitchell had in mind with this, but some relevance there. All right, well, let's move on to Astro 365. A couple of weeks ago from this day in 1953, Rosalind Franklin, then just 33 years old, discovered and documented through X-ray crystallography that the structure of DNA had two chains. There's a famous picture that she took, and she made some notes in her journal about the fact that there was definitely one phosphate group on the outside, and that she had determined that the DNA definitely had these two intertwined spiral structures in a helix shape. Well, she was in the same lab as Watson and Crick. They somehow got a hold of her picture without her knowing about it, and 2 weeks later, on this day, published their discovery of the double helix structure of DNA. Not only not giving her credit for the image, but later, after she had died of cancer, joked about how they got a hold of the image without her knowing about it. So, not exactly upscale folks. Of course, we now know the true story, but she was never given credit for that monumental discovery in the field of biology. But we know that she actually had the double helix structure worked out a couple weeks before Watson and Crick did. So anyways, that's what happened back in 1953 on this day. Unfortunately, the history of science, and in particular astronomy, is rife with examples of this, and we'll actually get to one of those in the news quiz, where like pretty incredible misogyny trumped the true discoverers of breakthroughs from getting credit. Some got vindicated, some did not. But let's get into the news quiz, and then we'll get to that example I was mentioning here. All right, here we go. Astronomers recently discovered a forbidden blank orbiting around a red dwarf star that is only about 4 times the size of Jupiter. A forbidden what?
Planet?
Planets. Yeah, forbidden planet. So the deal is it is forbidden because it is way, way too close to this red dwarf star and way, way too big. We think that the way that gas giants form requires that there is first a rocky core and then quite a bit of time for the gas to build up around that rocky core. The distance of this gas giant planet and the size of it relative to this pretty tiny M-class red dwarf star totally defies what we know about solar system formation. So there are going to have to be some changes based on that. But it's about a 1 to 4 size ratio here. All right, 1 point for Nick. Here we go. What did planetary scientist Robert Ward find near El Sauz, Texas last week? I'll give you a hint. He found it on the ground, but it hadn't been there for long.
I'm going to guess a meteorite fragment.
There you go. Nicely done, Amaya. Yeah, it was one of those meteorite fragments that was actually tracked. And so there was actually some Doppler radar projections of where this thing would have landed. And this guy does this for a living, apparently. He tracks meteors. And so he found the first piece of this one that landed in Texas last week. All right, that's 2 points total for Amaya. You have the lead. Here we go. Last Friday, February 24th, marked the discovery of the first blank by Dame Jocelyn Bell Burnell. This is the example that I was talking about earlier. What did she discover? She did not get the Nobel Prize for it. Her advisor did.
Is it a pulsar?
It was a pulsar.
Yeah.
Yeah, so she, here's her data back when she was a graduate student, not unlike Rosalind Franklin's, had the data, basically turned it over to her advisor. He's like, it's nothing, no big deal. And then he took it and published it and got a Nobel Prize for his discovery. But in this case, Jocelyn Bell Burnell was given the Breakthrough Prize in Physics, which carries with it not a $1 million prize like the Nobel, but a $3 million prize, which she donated to create a scholarship to get more women into the sciences. So take that, Nobel laureates. Yeah, pretty amazing woman. Jocelyn Bell Burnell. And she is a dame, by the way. It's almost like being a knight. All right. 1 point for Lauren. Here we go. The world's first 3D printed rocket will attempt to launch its first mission, called GLHF, from Cape Canaveral on March 8th. What does GLHF stand for? It's a little tongue-in-cheek.
Try to think of dumb acronyms here. Good luck, High Florida.
Oh, you got. We're gonna give you half a point for that, Nick. It is good luck. Yep, half a point for Nick.
High five.
Oh, so close.
Good luck,
So
high
close.
flyer.
Oh, so close. It's good luck. Have fun.
Oh.
But yeah, 3D printed rocket. It's pretty cool. And you can watch the video of some of the rocket sections being 3D printed. I mean, it is a pretty cool milestone. So I have high hopes that it will do well. So nobody gets the point for that one except for Nick getting a half point on that one. Yeah. Okay, here we go. NASA's Mars orbiter has confirmed that China's, I'm not sure if I pronounced this correctly, Zhurong rover has stayed stationary for over 5 months, indicating that it is still in blank mode.
Hibernation.
Hibernation mode. That is correct. So yeah, in the left-hand panel, you can see the rover near the top of the frame. It moved a little bit when it first got there, and it's just down to the right of the crater in the center pane. That was taken several months ago, and the most recent image taken over on the right, 5 months after the middle panel, has it not moving at all. It's been stationary for 5 months now, so not looking good for that rover, unfortunately. All right, that's 3 points for Amaya. You have the lead. All right, here we go. The U.S. government has approved Amazon's Project Blank, a constellation of over 3,200 satellites that will bring high-speed broadband connectivity to customers all over the globe.
Is that Cooper?
It is Cooper, Kuiper. I've heard it pronounced both ways. Yeah, so these are the rockets that are going to launch those satellites into orbit.
More things to worry about.
I know, it's really unfortunate. Wyoming Stargazing is actually giving a presentation about light pollution caused by satellite proliferation next week. So if you want to tune into that, we'll share some information about what is to come. It's not looking good, unfortunately. All right, moving on. Last week, the telescope that we refer to as the Margaret Burbidge Space Telescope, otherwise known as the JWST, discovered 6 distant black swan galaxies that formed just 700 million years after the Big Bang. They appear to have at least 1 to 2 orders of magnitude too many of what?
I feel like this has to be stars.
It is stars. Yeah, so these are really, really old galaxies. Everything we think about galaxy formation suggests that they should have like maybe 1 to 10% of the numbers of stars that galaxies like the Milky Way have. It turns out that the largest of these 6 galaxies, the little red dots there, has over 100 billion stars. How it formed 100 billion stars just 700 million years after the Big Bang is a bit of an anomaly. So if they actually turn out to have the number of stars that we think they have, we got the problem with how we think galaxies form in the universe. So very interesting stuff indeed.
Can I ask this? Maybe this is a stupid question.
No, please.
So who came up with should? Like who came up with how many should be associated with a galaxy?
Yeah, it's a
This
great
is not my
question.
field.
It's like the last 100 years of the theory of galactic evolution. I mean, Lauren knows this stuff way better than I do. Do you know like the names of the? Go for it, Lauren.
Oh, I don't know about names, but it's just you can sort of model how you think these sorts of galaxies are going to form. And particularly what really matters is how much like gas they can accrete from the universe in a given amount of time. So this is saying something that you must be gathering a lot more material more quickly and forming stars more effectively than we otherwise would think given the models. So
Is it relative to like is there a proportionate relationship to the size of the star at the center or like of their sun or something?
So this it's a whole collection of stars, right? So the black hole at the center maybe can regulate how other stars might form. So that might be something if it's not throwing out as much gas or if they're exploding differently than we would have thought or if it's a little bit denser or it's definitely interesting to think about.
Cool. Thank you.
The question I was going to ask though is, do we know the error bars on these measurements? Because the other flip side of it isn't just that the theory is wrong.
They are really big. We can just say that these are just candidate galaxies at the moment. There are some like ground-based observations. I think the Hubble Space Telescope took the first pictures of these. I think there have been a couple ground-based observations as well, but we are still waiting for confirmation about the true number of stars in these galaxies. And Maya, looked like you were going to say something.
Oh, I just have a couple of questions, but I haven't had a chance to read this paper, so like they're basically like I assume the resolution's way too low to like even try to understand this, but like do we kind of know like the rough like how metal rich or poor the stars in this galaxy were? Because I'd be interested in that.
No, I don't think we have spectra on these yet.
Do we even know if there are any like star forming regions or if these were already old at this time?
That's a great question. I don't know. I'm not sure actually even if the James Webb has capabilities of getting a spectra on these. I think they may be too small in the field of view, but that's a really great question. I don't know.
Yeah, I don't know for certain, but I think if they're at that high of a redshift to be visible with James Webb, they have to be pretty star forming.
That makes sense.
Because of how it shifts. Also be very shocking if they were old this early on. That would be.
Yeah, I mean, they can't be that old, like less than 1 billion years. Yeah, I mean, I don't remember what the redshift number was, but I mean, we're talking 13 point something billion light years away. They're about as far away as we can see. Cool. Thanks for those questions. That was great. All right, moving along. Published last week in the Physics Archive blog, researchers from the University of Georgia are arguing for a more restrictive habitable zone for identifying exoplanets that might harbor life. There are only 5 currently known planets in this new habitable zone called the blank habitable zone.
The Goldilocks Platinum Supreme Club.
I feel like you should get a point for that. Nope, that's not it. It's more mundane and scientific, believe it or not.
What, more scientific than Goldilocks? Get out of here.
Think plant life.
Tree habitable zone?
You're on the right track, Amaya. You're on the right track. It is the photosynthetic habitable zone. So it turns out if you just look for where liquid water might exist, it doesn't give you the full picture. You also have to look at the wavelength of light that is most strongly emitted by the star of the planet, type of the star, age of the star, what kind of orbit the planet is in. Is it tidally locked? Is it not partially tidally locked? And when you put all those factors in, the habitable zone shrinks dramatically, such that, like the 30 or 40 planets that I think that we've identified that were in the the water habitable zone get limited down to 5. It's all part of, I think, 2 systems identified by the Kepler Space Telescope. So yeah, out of that whole slew, there are only 5 that fit this much more limited habitable zone. So maybe good, right, for limiting where the James Webb Space Telescope or the Margaret Burbidge Space Telescope points. Instead of having to choose from 40, you can choose from 5.
Certainly narrows down the vacation options here.
It does. Yeah. It turns out the really close ones too, the ones out at about 10 light years did not make the cut, unfortunately. We're looking more like 100 light years away at the smallest amount.
I think it's useful to know which of those planets would fall into that kind of thing, but it feels incredibly unimaginative to think all life must look exactly like the plants that we have when there's even life on Earth that exists outside of that sort of requirement.
This is all very geocentric thinking.
Yeah. That's never been a problem in the past before.
No, never. Yeah, we'll just leave it at that. Okay, a group of, this one's even better. A group of U.S. scientists, only from the U.S. could this happen, recently proposed this unorthodox, or maybe not so unorthodox scheme to combat global warming.
I've seen a couple of different weird theories. I'm going to go with the one that's like from the Mistborn books and say it's clouding the atmosphere with ash.
We're going to give that to you. It's moon dust. Yeah. So yeah, these guys calculated that if you kick up enough moon dust between the Earth and the sun, it will block out just the right amount of solar radiation you need every month. You have to keep kicking up moon dust every month to get the right amount of solar radiation. But the idea is just to like give us a bit more time to start limiting carbon dioxide emissions on Earth. So it's not like a final solution, but maybe it buys us like another 100 years or something. And since we're going to be on the moon anyways, we're going to be kicking up dust regardless. Might as well try to do it in the right direction, right? That's not going to cause any problems. All that moon dust is going to go right back down onto the moon.
Out of curiosity, did they say how much, like, in terms of like tonnage dust per month we need?
Yes, it is a ridiculous amount of moon dust. I don't remember the total. It is like many thousands of tons of moon dust. But I mean, right now it's not being used for anything, right? I did not read the entirety of this paper. But yeah, it's oh man, yeah. Anyways, moving on. In other astronomy-related news of things showing up where they are just not supposed to be, a blank was discovered at the wrong distance around the dwarf planet Quorar. What was discovered around Quorar just recently?
Moon?
Not a moon. It should have been a moon.
Space station.
Black hole. I don't know.
Man, I wish it was a space station. That would have been pretty cool. Nope. Think Saturn. Not a moon.
Ring.
Yeah, nice, Danny. Danny gets a point. Yeah, so at the distance where this ring is around Quorar, all of our theories about moon formation and ring formation suggests this should have been a moon, but it's not. So it was a moon that either got smacked by something and broken apart, or we need to revise our theory about how moons form around planetary bodies. But yeah, not the first dwarf planet to have rings. I think there are actually 2 others that have rings, but this one's apparently at the wrong location for planetary theory. So it goes. Okay, what recently discovered new form of water ice might have huge implications for understanding water ice in the rest of the universe? I didn't know there were different types of water ice. turns out there are quite a few.
Like some sort of high pressure variant, or?
Yes, that was my first thought when I read this. They must be putting like water under like really high pressure, but I mean, no. Turns out that this is like you could make this at your house if you had the right contraption.
Is it a metallic solution or something?
No, it's not a metallic solution. Yeah, I had no idea this even existed. So here's what it looks like. It's called medium density amorphous ice. And it sounds really technical. What they did is they put ice cubes in this little container with these steel ball bearings, and they shook it really, really hard. And apparently what that does is it breaks up the crystal lattice structure. But they did it with really, really, really cold ice. I don't remember the exact temperature, but really, 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 really cold. And apparently, if you shake really, really cold ice long enough and you have something to stimulate it, like these steel ball bearings, you can actually change the crystal lattice structure of the ice. And you get these globs of ice. And the reason why this one is so interesting is because just like with the black hole mass gap, there was also a ice mass gap between like high density and low density amorphous ice. This is the first time anyone has seen medium density amorphous ice. And we didn't know it existed, but it turns out it does. And maybe this is actually the most common form of ice out there in the universe. We have a really hard time collecting it, obviously, but it might be actually what exists on the moon. Could actually be what exists in comets as well. The problem is when we actually get to, sample the ice from comets, it's all sublimating because it's close to the sun. But maybe this is actually what populates the majority of ice reserves out there in the universe. We don't know yet, but yeah, brand new form of ice.
So is it basically like a slushy?
No, it's like solid chunks. It just
Sorry.
sloshy, actually. Yeah, I don't know a ton about it, but
Okay.
apparently that's the deal. Oh yeah, and Maggie got the number for us. It's 11 million tons of moon dust every year to provide just the right amount of shielding. Great. All right, so yeah, about almost 1 million tons a month. Okay, a couple more questions. Here we go. 2 days ago, what replacement spacecraft docked at the International Space Station after its predecessor suffered a coolant leak back in December?
Soyuz.
Soyuz! Yeah, 2 points for Danny. Nice work. The Soyuz MS-23, to be precise. So yeah, now some astronauts get to go home, which is fantastic. And actually, that was the last question of the news quiz. And I think Amaya is our champion with 4 correct answers. Nice work, Amaya.
Thanks.
All right, let's see here. Oh yeah, what's up, Dr. Sam? There is a really cool conjunction of Venus and Jupiter coming up tomorrow, in fact. So for all you early risers out there, you don't have to worry about it. This is actually not coming up in the morning. This is going to be right after sunset. So it's definitely better for us night owls. So just after the sun sets tomorrow, look to the west, and you should see 2 beautiful points of light almost on top of each other. They're going to be less than a full moon apart, which is pretty cool. And so, yeah, grab a pair of binoculars or a spotting scope or a telescope or just like a camera, and you should be able to get a pretty cool picture of the 2 brightest points in the night sky, other than the moon and artificial satellites. But yeah, these ones won't be moving that fast. So yeah, check these out tomorrow morning. It should be, or excuse me, tomorrow evening. It should be pretty cool. All righty. Well, that brings us to our special guest spot. Amaya, thanks so much for joining us for the first half of the show. And again, love to hear a little bit about how you got into astronomy and what you're up to these days.
In terms of getting into astronomy, probably just like the classic, my parents showed me Star Wars when I was little, and I was like, that's what I want to do. And as it turns out, you can't do that, but you can study space. So yeah, it was really that. Honestly, like in terms of movies that kind of got me into space, The Martian really did it too.
Oh, nice.
I love The Martian. And yeah, as to what I'm doing now, I'm in the second year of my PhD program at University of Utah. I actually did my undergrad at the University of Texas. Sorry, Nick, we didn't overlap. I graduated like 2 years ago. But yeah, so I study the chemistry of open clusters. So basically, in terms of like the top level science that we're interested in, we want to learn about how how galaxies evolve and their structure. The best way to do that is to learn about our galaxy, the Milky Way. And one of the best ways to learn about our galaxy is by studying just the stars that are in it, because it'll tell us about the birth conditions of those stars, like the gas and dust that they formed from, and then how they move about in the galaxy. Since most stars like form in open clusters and then like slowly disperse as they get older, open clusters are kind of the best place to study their chemistry, which is how I ended up doing this research project. So yeah, that's kind of what I do. Very
cool.
Yeah.
And so you're also helping out with a couple undergraduate classes?
Yes, the class that I've taught for the past 4 semesters now is the Introductory Electricity and Magnetism for pre-meds. So I know way too much about the human eye now than I ever thought I would otherwise. But yeah, it's really fun. They have a test coming up tomorrow, and I hope they do well.
Nice. I hope they do as well.
Yeah.
So what are your thoughts on what you're going to do after your PhD? Any thinking about that? Are you going to stay in with professional astronomy, go into teaching? What do you think?
Probably not professional teaching. I'm at this point in my career still torn between like, do I want to do a postdoc? Because the idea of just being paid to sit down and just do research sounds really nice. But also there are jobs in like data science industry where I could probably continue doing similar like computational work, which also seem interesting, but it varies day by day. Today is a postdoc day. Today I'm leaning towards I want to stay and just do research for a while.
Nice.
Yeah.
And you think you'd want to continue doing the same type of research on open star clusters, or are you thinking about other things as well?
So I don't know if it's specifically open star clusters, but I just have a lot of questions about the chemistry of stars. Doesn't really matter where they come from. When I was applying for the NSF like research fellowship in the fall, I wrote my proposal on studying binaries to determine like if we could determine whether the clusters were chemically homogeneous or whether binaries could like affect their chemistry of each other. So that's one question I'd be interested in, just like learning what the gas and dust between clusters or like between the stars in the clusters also seems really interesting. Yeah.
Nice.
Yeah. I would love to learn about stars in other galaxies, but they're too far away. So.
Yeah. Can the James Webb not resolve open clusters? I bet it could.
We can resolve star forming regions in Andromeda and I think a few other nearby galaxies, but we don't have like the resolution to get individual spectra from individual stars because it's too far away.
Gotcha.
Very sad. So yeah. All of my stuff is limited to like this side of the Milky Way.
Okay. So like the LMC or the SMC are also too far?
I don't think those are too far. I know a couple of members of like in my research group who study the Magellanic Clouds. I just mainly study use Gaia and apogee data, so like SDSS-4 and SDSS-5 when that comes out. So most of my stuff is limited to just the disk of the galaxy.
No, there are plenty of stars in the Milky Way.
Oh yeah. But we're surrounded by my favorite, so.
Nice.
Yeah, I was going to ask the general thinking, the thing that you learn in classes that, open clusters all have the same metallicity, the same chemical composition, stars inside them. They all form together, so they look alike.
One of my favorite things my advisor told me when I started my PhD was, so we told you this in intro astronomy. That was a lie.
Yeah. So how much of a lie is it? Is it just a blatant lie where it's not true at all? Or is it sort of true at least? Or
I think to the first order kind of true, because the project that I'm working on is specifically constraining the abundance scatter within a cluster, and typically it's on the order of 0 point whatever dex. In case people don't know, that's the measurement of how much metal or chemistry, or how much element is in a star that we can measure. So 0.04 or whatever, that's pretty small.
Mm-hmm.
So they're not homogeneous, I would say, but they're very close to homogeneous. Yeah, it's fun.
Yeah.
I spent a lot of time just a surprising amount of my project was just re-verifying uncertainties calculated by different surveys, because I needed to make sure my values were right and not just miscalculated uncertainties. Mm-hmm. It was a good time.
Yeah. Good news for me though, because in the simulations you don't get anywhere close to star by star.
No.
It's sort of here is a particle that has many thousands of stars in this one thing, and so knowing that it's mostly okay to call them the same is reassuring.
Oh yeah. I would say for anyone who's not specifically focused on what is the chemistry of how does the chemistry differ between 6 different clusters, they're homogeneous. Don't worry.
But is the small discrepancy enough to lead to new understandings about how these clusters formed or what they mean about the galaxies that they're found in?
I would love to know, and I will let you know once I finish my paper. But yeah, that's kind of what we're looking at. So the reason I can't answer that right now is because what I'm doing is based on a previous paper that a previous grad student did, and he found some correlations between the tiny intrinsic scatters of different elements and how they scaled with the cluster mass. But there were some issues with the way that he calculated the cluster mass, so I had to recalculate them, and then it turns out those correlations didn't exist. So now we're back to we have these very small abundant scatters, but do they tell us anything about the initial molecular cloud that formed these stars, or is it just the cloud was kind of inhomogeneous when it formed? So that's what we're trying to work out.
Cool. Well, best of luck. Can't wait to hear the results.
Yeah, it'll be fun.
When you were talking about the first order truth or not, I was reminded when I first asked my my astronomy professor in college, my mentor, about how the fact that okay, so I think I understand the process by which hydrogen is fused into helium, and all the other elements are basically just a more complicated process of that, right, inside the core of stars. And he's actually it's a bit more complicated than that. It has learn more about that, and I haven't studied that stuff in a long time, but yeah, stellar nuclear synthesis is not just fusion in the cores of stars. It is there is a bit more that goes into that.
One of the coolest things I learned about that is just when stars, when they go into the red giant phase, sometimes the convection belts in the star can dredge up metals from the core and put them on the surface, which is just the idea of a convection belt stretching from the surface of a star all the way down to its core is wild to me.
Yeah, I guess with the red giant as well, that's maybe the size of a convection belt the size of our solar system.
I love stars. They're really cool. Some people say they're the more boring part of astronomy, but I would disagree. And by some people, I mean my roommates.
Oh, that's good stuff. Yeah, the half truths that we are told in school.
I mean, anyone who's taken a physics class knows how many times they just say it's proportional to this and just move on. So,
Do you have a favorite cluster that you like to look at, or?
yes, NGC 6791 is really pretty. It's really well studied too. I think it's either going to be a tie between that or 6819. Both of them are really well studied, and they just have a lot of stars. So all my plots look really pretty when I do them.
Nice. Which constellations are those closest to?
I do not know.
Okay.
My knowledge of constellations is actually, quite frankly, lacking.
I mean, you're in like great company. I think most astronomers do not know their constellations. I'm an educator. That's why I know my constellations.
It's just awkward because like my partner, she's also a grad student, but she was a park ranger, so she knows all the constellations off the top of her head, and I'm just like, how do you do this?
It doesn't take that long. You really you spend like one summer season and one winter season out doing stargazing, and like then you got it.
That's good to know.
It's
Yeah.
between Lyra and Cygnus,
Lyra and Cygnus.
according to Wikipedia.
Nice. Yeah, good summertime observing there.
I think it's also funny too, though. So when I taught, I knew the winter sky decently well, but I was teaching from New York City. And so you can see like the brightest stars in the constellation. That's pretty much it. And then as soon as I went somewhere darker, I was like, there are too many stars in the sky.
Yeah.
I can no longer find these constellations. Suddenly I was useless again.
Yeah, I mean, that is a problem that I love to have in Wyoming, actually. Yeah. On moonless nights, it is hard to pick out all but the brightest constellations because of all the stars that we have there. It is a great problem. I wish more people had that problem in more places.
I only recently saw the Andromeda for the first time when I went to Death Valley, and that was a nice experience.
Isn't that cool? Yeah, we can easily see Andromeda on moonless nights throughout the year.
I'm so jealous.
Jackson. Yeah, it's pretty cool.
Yeah, that makes me think about the quote in traveling, because the story that sort of came to my mind, I'm realizing now, is the first time I went to the Southern Hemisphere, and you get to see the large and small Magellanic Clouds. They're just like hanging out in the sky, and you're like, this is amazing.
Yeah.
Being able to look up and see a different galaxy is wild if you're from the Northern Hemisphere.
Totally, right? I mean, you don't even need that dark of a night to see them in the Southern Hemisphere either. It's pretty profound. Yeah,
I was disproportionately excited compared to everyone around me. I was like, why are you freaking out? Like, it's so cool.
It is pretty wild.
Yeah.
Well, we're just about out of time, but we started a little bit late. I thought it might be fun just for everybody just to give some quick updates about what you're working on in your research, what's new in your astronomical or medical aerospace world. So anyone can start us off, and then we'll wrap things up.
I'll update you guys.
Sweet.
So the last 3 weeks, this is my 4th week on this block. I've been on the emergency general surgery service. This particular service is known to be a very, very busy service with lots of patients that we tend to carry. Plus, I think I did 25 cases last week, which range from anywhere between small peritoneal dialysis catheter placements or revisions to what we call XLAPs, exploratory laparotomies, where you make an incision from basically the xiphoid all the way down to almost to the pubis. So big, long belly incision, and fix whatever's wrong. So that was the majority of last week. And so that's what I've been up to.
Wow. That's incredible. I've got one of those scars, so I know what you're talking about.
You have an XLAP scar?
Not that. Mine's only 6 inches long, but
still.
Yeah.
Still.
Yeah. Yep.
Cool.
You said this is your last week, Danny?
Yes, and then I go to trauma.
Oh, I was gonna say, I hope you get to sleep, but trauma sounds like the opposite of that.
In April. We'll be calmer in
Flying
April.
pan into the fire on that one.
Yeah.
So, yeah, and actually, where I'm located geographically, there are it's actually been documented in the last few years. There's been a rise in the volume of penetrating trauma that we see, particularly gun violence, and so we just see a lot of stuff come through the trauma bay, which for better or for worse. So obviously, it's not a great thing for the community. For surgical training, it's beneficial to see those kinds of things, but in the bigger picture, nobody wants that. That's not a good thing. But anyway, so that's what I'm up to. Who else?
My update's much less exciting. I've been picking back up on some research that I've been doing. So I run these big cosmological galaxy simulations, and I like to use them to make predictions of different types of things that future telescopes could see. So one project in particular that I'm working on is called Aspera. So it's looking for specific wavelengths of light around galaxies. And I made some predictions for them in the past, but it's time to update all of the models that go into that. And actually my group has been working on simulating a few other galaxies. So before we just had one, now we had 6, which is a pretty big sample for galaxies of this size. It's taken us years to run these 6 galaxies. So I get to make some new predictions for that. And hopefully the telescope is going to be able to see them all. But it's definitely going to help us try and pick which real targets do we want to look at in the sky, and how long do we think we have to look at them to be able to find this light. So it's exciting. It's a lot of nitty gritty, oh, it crashed, this model, and just trying to troubleshoot again and again, but it's getting there. And I'm pretty pleased with how it's going.
Nice. Glad things are going well.
Yeah.
I guess on my end, I just spent 2 days on a review call, which is 4 hours each day on Zoom, which is a lot. Been running through the final kind of checklist for the telescope we've been working on before it goes down to Chile. And so by and large, looking good. There's a lot of really, really cool testing we did in the lab to understand its optical properties and its, kind of different performance metrics and detector performance and noise performance, all of the above. And there's always a few hiccups. It's experimental physics after all. There's always something, but by and large, it looks pretty good, and looks like we're ready to go down to Chile. So next step is packing. I'm not buying a ticket down there yet, but it's not too far off at this point where I'm going to be down in Chile for a while. So looking forward to that, and good to see some movement.
Nice. What's the? Sorry. Go ahead, Jenny.
No, I was going. How long do you anticipate being down there?
Probably 2 to 3 months.
And what's the timeline on it heading down there?
Let's see here. I think the goal is to pack up in the next month or something like that. And you're going to kind of pack up an entire lab and throw it in containers, and then it takes depending. There's some variables in shipping these days, but somewhere between 4 to 8 weeks to actually make it by boat down to Chile and up to the site. And then once that gets up to the site, we go down there and meet it, and have to undo it all, unpack it, rebuild it, retest it, and then get it up on its mount to start observations. But looks like we'll be starting observations, I'd guess right now in July, August is kind of what it's looking like. So
that's super cool.
Yeah. New telescope on the sky soon.
Yeah. What's the timeline from when you first started working on that project until first
it started in 2016 is the inception of the project. Then we kind of started from square one. A lot of technology and expertise and background in there, so it's not like we had nothing to go off of, but we hadn't really blank slate as far as the design goes and ordering parts and all that stuff. So it's looks like it's going to be about 7 years.
Wow.
And I think we've been very actively building it for the last since 2019, so the last 3 or 4 years. Yeah.
Wow.
That's pretty fast. I'm impressed.
Yeah.
Do you run an instrumentation lab at UT?
Yeah.
Oh, that's so nice. One of my friends.
I should say I don't run it yet. They're still putting it together.
One of my friends was into the instrumentation side of astronomy, but we didn't have one before they graduated. So
Yeah,
Just out of time.
just out of time. Yeah, well, we're putting that together at UT. There's a number of different experimental programs starting up here, so that's fun. Yeah.
Nice. Thanks for sharing, everybody. Nothing huge in my world. My daughter turned 6 months old this week. That was kind of cool. Yeah, the observatory and planetarium that I've been helping to develop in Jackson is definitely got some legs. We're looking at a grand opening ceremony in October. So that's pretty exciting. Yeah, it's good stuff.
All right, party in Jackson.
Congrats.
Yeah, definitely. I mean, my plan is to host the Astro Show from up there at the observatory. So yeah, if y'all got the second weekend in October available, you should come on down. It's also going to be a partial solar eclipse. Not quite as cool as the 2017 total solar eclipse, like not even in the same like remote ballpark. But I mean, partial eclipses are still nice to see with eclipse glasses and solar filters. So yeah, it's like I think we get like 75%. In Jackson, a little bit farther south of us, gets an annular eclipse, which is even cooler. That's when you get just like a ring of sun with the moon like right in the center, but the moon's just too far away from the Earth to block the entire solar disk. So it goes. Well, Amaya, I always like to give the final word to the special guest, and so if you have any words of wisdom you'd like to offer aspiring astronomers or folks considering going into STEM fields, or any other experience you've had in the astronomical community that you want to share, and favorite story, whatever you like, floor is yours.
I mean, in terms of just like getting into STEM or just sticking with it, I guess the best lesson I've learned is it's like maybe 3% how smart you are and like 99% just can you stick with it. It's like the best case of like the effort you put in and not how talented you are is what I found, because a lot of people who are smarter than me aren't in PhD programs anymore, but here I am just chugging away. And I feel like that's in all areas of life, not to like wax too poetic or broad, but I feel like the lesson holds.
Yeah, I definitely agree. I think I'm like an averagely intelligent person, but yeah, I worked really, really hard in the face of a lot of difficulties, as I'm sure we all did. We're in the room right now, so.
Oh, in one piece of like semi-humor advice, if you do go to grad school, find roommates with cats, because they're very useful when you're tired and stressed.
Indeed. Yeah, animals do have a lovely stress reduction quality to them. You shared a joke earlier, Amaya. It was one of these like wonderful pieces of astronomy humor. I think that would be a fantastic way to wrap up the show this evening.
Yeah, what's a star's favorite kind of food? It's fusion.
Nice. I love it. Well, Amaya, thank you so much for joining us this evening. We really appreciate your time.
Thank you for having me.
Yeah, it's been a blast. Our operations director, Maggie, will reach out to you for give you a thank you gift. So thanks again. And thanks as always to the co-stars. Wouldn't have a show without you. So thank you so much for bringing all your expertise and enthusiasm to the Astro Show. Thanks to all the folks behind the scene, especially Maggie, our operations director, Wyoming Stargazing Board of Directors, all of our supporters, and all of you watching at home. We really appreciate you tuning in. And if you're not watching live, we hope you enjoy the recording. If you ever have any comments, give us a ring. We would love to hear from you. You can always chat your comments during the show, or just send an email to info@wyomingstargazing.org. So we hope to see you in a couple weeks. Until then, be well, and don't forget to look up. We'll see you next time. Bye.